Okay. Uh, so you can see me and you can hear me, no? You can see me and you can hear me, no? Ah, okay, thank you. Okay. So we will try to do this one, okay? Actually, for the exam also, you will get this kind of questions, okay? If you know the if you have the basic understanding about the vector and those surface and line integral, surface and volume integral, you can do the question easily. Okay. Okay. Now, so first thing you have to understand, this is related with Cartesian coordinate. Okay. Rectangular coordinate. Rectangular coordinate. Okay. This is related with the rectangular coordinate. Okay. So an electric field in free space is given. Okay. So this is Z axis. This is Y axis. This is X axis. Okay. So this electric field is in free space is given using this function. Okay. So the direction is given. Okay. So what is the direction? That is in Z direction. Okay. So E field in Z direction. That E field is in Z direction. Okay. So that E field is like this in Z direction. This is in Z direction. Okay. A is okay. Find the total charge contained within a cube centered at the origin of 4 meter side length. Center එක origin එකේ center එක origin එකේ 4 meter side length of 4 meter side length. 4 meter side length means like this, no? 4 meter from here to here. So this will be 2 meter. This will be minus 2 meter because the center at the origin. Okay. So here also 2 meter minus 2 meter, 2 meter minus 2 meter. So there is a rectangular like this. Okay. There is a rectangle like this. Like this, there is a rectangle. Okay. So there is a rectangle like this. I can't draw it clearly. Okay. Yeah, ඉන්න ගියපම තමයි එපා වෙන්නේ. Okay. Like I said, this is y, this is x. මේකට අර මේ අත පාවිච්චි කරලා තමයි ගන්න ඕනේ. හරි. එතකොට මේක එන්නේ නැත්නම් දෙක හරි. එතකොට මේක එන්නේ මෙහෙම මෙතන යනවා දෙකට යන කලින් මේ පැත්තටත් එනවා මේ පැත්තටත් එනවා. හරි. ඊට පස්සේ මෙහෙම එනවා. එතන කවුද දෙකකින් ඊට පස්සේ අපිට වෙන දෙකකින්. හරි. ඔන්න ඔය වගේ එකක් නෙමෙයි. Okay. මේක rectangle එකක්. So it is a rectangular like this. Okay. This is a maximum diagram I can draw. Okay. Okay. So uh, this kind of cube you will get. Okay. So it is a rectangle. ඝනකාවයක් නේ. It's a ඝනකාවයක්. හරි. පැති ඔක්කොම සමානයි. Okay. All sides are equal. Okay. So we have to the find the total charge contained within the cube. Okay. Okay. Now tell me. So this E field is in Z direction like this. Z direction. Okay. So this E field in Z direction. Okay. This E field in Z direction. Okay. So Gaussian law, we know that Gaussian law is phi u, that electric flux is equal to we should do the surface integral ds ds. Okay. And also we know that E E sorry ds is equal to epsilon E. Okay, ds is equal to epsilon E. We know this relationship also. Okay, so this relationship also we have to apply. Okay, d is equal to epsilon E. Okay, so uh, now find the total charge contained within the cube. Okay, so this is again equal to cube. Okay, so you have to find the total charge. Okay, now if you consider total flux, okay, contained within the cube, that flux should be in Z direction. Should be in Z direction. Okay, so that is not in this direction nor this direction. So it is only in Z direction. Okay. So if you consider this cube, this electric flux only cut this surface, this is the top surface, this surface and this surface, the bottom surface, this bottom surface. Okay. So this is in XY plane. Okay. So this surface are in XY plane. Okay. Did you understand? I hope you should understand this. Okay. So don't worry about the Q. Okay. Don't worry about Q. Okay. Just think phi. Electric flux. Okay. So electric flux are in one direction now. Okay. So if you consider this Q, this E is in Z direction. So the flux also should be in Z direction, not in Y or X direction. Okay. Not in Y or X direction. It is only in Z direction. That means these flux are only in XY plane. So one XY plane is here. Actually, that is Z is equal to -2. This plane is Z is equal to 2. Sorry, 2. And this plane is, the bottom plane is, what is the Z coordinate for the bottom plane? Bottom plane. Z is equal to -2. Okay, Z is equal to 2 and Z is equal to -2. Okay, so only this surface are related with the flux. Okay, so only this surface also should be related with the charge. Okay, so you have to apply the Gauss law to find the total charges or total flux through this two plane. That is it. So again, you have to do a surface integration. Okay. So surface integration you should do with respect to what variable? What variable should you should need to do the surface integral? What is the variables? What are the variable you need? You need to do the integral with respect to which variable? With respect to which variable? Is that in Z plane? Sorry, XY plane. Okay, so if I consider it is just like one. Okay, This is x, this is y. Okay. So there is one plane that is z is equal to -2. Okay. So if you the find the surface of this integrate if of this surface, okay. the- If you want to find the area of this surface, so with what are the variables you need to do the integration. You need to find the way find this area. So what are the variables? You have to do the integration with respect to x and y, no? Because z is a constant. Okay. And if you consider other part, that is z is equal to +2. Again, you have to do the integration with respect to x and y plane. Okay. So that is very easy actually. I think you can do this by yourself. Okay. So, okay, tell me, tell me, don't get much time, okay? Please give an answer. The answer may be wrong or correct. Don't worry. Give me an answer as you can understand, okay? So, to find, okay, so first let's find the magnetic flux. Let's find the magnetic flux to Z equal +2 XY plane. You, you need to find the magnetic, sorry, not magnetic flux, electrical flux. Okay, electric flux. You need to find the electric flux. Electric flux, okay, uh, to the surface, to the surface at Z is equal -2. Okay, so this plane is in XY plane. Okay, so let's say that you need to find the electrical flux. Okay, so you know the electric field E that is given. Okay, and you know D, epsilon E. This is the flux density. Okay, so if you need to find the flux, electric flux, you can use Gaussian law, that is ds. Okay, so instead of this D, you can apply epsilon E here. Okay, so that is equal, D is equal to epsilon E. So you can directly apply phi is equal to, you need to do the surface integral E epsilon naught E ds. Okay, so this E is in Z axis. Okay, so this E in Z uh, direction. Okay, so this is the Z direction unit vector. Okay, so this is the Z direction unit vector. Okay, now if it is Z direction and ZY plane, you have to do this integration with respect to x and with respect to y. Okay, y. So your uh, function is there. So your function is what? D is equal to 5z epsilon naught into epsilon naught. Okay, so again it is 5z square. Okay, so if you consider D is equal to epsilon E. Okay, so epsilon naught E means 5 epsilon naught. 5 is at this square epsilon naught. Epsilon cancel. So you will have only 5 is at this square. So this is the D. Okay, flux density. Okay, then you can apply flux density here, that function here. That is uh, 5 is at this square. This is your function. 5 is at this square. 5 is at this square, and this is the direction. A is at hat. Okay, A is at hat. A is at hat. Okay, so you need to do the integration with dx and dy. Okay, with respect to dy and dx. Okay, and there is no any variables coming with this y and x, dy and dy and dx. Okay, in spherical and cylindrical coordinates, there is another term here also. But in this case, no terms here, only dy and dx. Okay, but this, these are the uh, directions are also included with this one. Okay, then we have to apply the z direction here. Okay, then again you have dot product. So dot product of unit vector to unit vector, the same unit vector. So that answer will be 1. Okay, I told you. Okay, then you have to do the integration with respect to x and with respect to y. Phi z, phi z square, phi z square dy dz, dy dx. Okay. Okay. Now tell me what is the x limit and what are the y limits? Tell me what is x limit? What is x limit? What is x limit? So this cubic is centered with 4 meter. So what is x limit? That is very easy. That is the only thing you need to understand. Okay. So you need to understand with respect to which parameter we should do the integration. Then you need to verify the limits. That's all. If you have found those clearly, I hope you can get uh, most of the, you can go for a high mark, okay? So most of the marks will be dependent on that part, choosing the things, okay? Not for the integration. I don't know, Dr. Udesh will be making the paper, okay? And I don't know, maybe he also maybe evaluate the paper, okay? But that is very important, okay? Finding the limits and finding the variables. Okay, now tell me what is the x-axis limits. Very easy, okay? X-axis limit එක කියන්න බලන්න. X-axis limit එකයි y-axis limit එකයි. දැන් මම මේ රූප සටහන අඳිනකොට ඒවා කීවා. ඒවා අඳිනකොට. Yes, very good. Okay. Thank you. Okay. So that is from x limit is from -2 to +2, -2 to +2. This y z is also -2 to +2. Okay. So sorry, here -2 to +2, -2 to +2. Here also -2 to +2. Okay. So what is the answer you will get? Okay. dy -2 to +2, 2 minus -2, you will have 4. Again, you will have 2 minus 2, you will have 4. So 4 into 4, 5 z square. This is the electric flux in xy plane at z is equal to 2. Okay, z is equal to 2. Now again we need to find the phi. Okay, we need to find the phi that is also in xy plane, but this is z is equal to -2. Okay, so if z is equal to +2, no? Okay. So here you can apply +2 instead of z. Okay, So same way, we have to consider the xy in Z also. Okay. So how we can calculate it? The same way, okay, same way. Uh, so mm, is correct, no problem. Okay. When we are finding the xy z is equal to -2, okay. Again, you have to do the surface integration with respect to x and y, okay. And your function is there, that is 5z, okay. This a z, I hope this should be in minus a z. Because when you are considering minus side, okay, you have to consider minus direction. Maybe can you remember that? Maybe I can't remember, unfortunately, that example. When I do example, okay, when I do example in chapter 2, actually in the first example, chapter 2, okay. Maybe this one. No, I can't remember. Can you remember that? Uh, can you remember that so as I can remember, it is just like this, okay? We find we find uh, the E field uh, due to two charges using the Coulomb's law. Okay. Then according to our logic, we need to add them together. No, but actually it is not added, it is subtract. Okay, we couldn't find why. What is the reason for that? Maybe you can remember that thing. Okay. So actually, I checked with Dr. Udesh. Okay, actually, we have to do the integration. Okay, sorry, we have to do a subtraction there, because when we are doing, okay, when we are doing, uh, so here, so in Z minus direction, no? This is Z minus direction. Okay, so we have to consider the E field in this way, in this direction, minus side. Okay, okay. So normally E field is in this direction, A is at, no, this should be, yeah, like this, okay? No, don't just forget it, okay? just forget it. Actually, that is not relevant with this one. Okay. So here the E field is a Z, E field is in Z direction. We can't change that. Okay. And also you have to do the integration with respect to dx and dy. Okay. But when you are doing this integration, so Z axis, now you have to consider the Z direction in minus directions because you consider minus 2. So the Z direction is now minus. A Z minus. Okay. So here the direction will be A Z minus. Actually. This should be minus A Z. Okay. So the same way you can do the integration and you will have minus this value. Minus this value. Then you have to find the total E field, to find the total 5 flux, you need to add them together. So you will have 0. Okay. So answer should be 0 here. Okay. So here we have to consider the minus direction. Okay. Because we are considering minus is a direction. Okay. So here we have to do the minus direction. So A is at, so those are two unit vectors. Okay. So it will be 1 and minus mark is there. So it will be minus 1. Okay. So I think it should be like this. Okay. So answer should be 0. Uh, Anyway, I will check it also with Dr. Udesh. Okay. So if there is any change, I will let you know. Okay. Otherwise, don't worry. This will be okay. Okay. So if my logic is not uh, correct, because normally if you are finding the flux density with the minus and plus side, it will be 0. Okay. The same thing happened in that one. Okay. So I got that from Dr. Udesh actually. Okay. Okay. So I think that should be 0. Okay. That should be 0. Okay. So try to understand it. If there is any change, I will let you know. Okay. If these two should be added, I will let you know. Okay. I think this is wrong. Okay. This is wrong. This should be subtract. Okay. 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 I think now we have done one example with related to spherical coordinate, one example with related to Cartesian coordinate. Okay. And I will do this one with related to, this is from, so you can understand the rho is there. And also this is a cylindrical surface. Okay. So definitely cylindrical coordinate systems are used here. Cylindrical coordinate system. Okay. So I will do this one also. Same thing actually we have to do. Okay. I hope. Okay. The same thing we have to do. But anyway, I will try to do this one. Okay. Uh, 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 so, so maybe you can understand it. Okay. So one example is related with Cartesian coordinate, this one. The previously we have done one example related with the sphere coordinate. This is related with cylindrical coordinate. Okay. This one. I will take this one. Okay. Okay. So here cylindrical coordinate system is used. You need to understand that one. Okay. So we have Z, Y, x-axis. Okay. Z on x-axis. Okay. So cylindrical surface, rho is equal to rho is this area, the radius of the cylinder. Okay. So cylinder is like this. Okay, cylinder is like this. Okay, so this is the area, the surface. Okay, so rho is equal to 8 centimeter. Okay, so this is in centimeter. So when you are doing this, you have to convert it to meter. Okay, don't forget it. You have to convert it to meter. So the charge density, it said that surface charge density. So surface charge density is given. Surface charge density is given. That is 5E. Wait a minute. Hello, මම lecture ඉන්නේ. Okay. Um, so that is 5E minus 20. Hmm. It's a magnitude descent. Okay. This is a magnitude descent. Okay, we will try to do this. Okay. Let's see whether we can do the integration or not. Anyway, we will try to understand the concept at least. Okay, maybe we can't do the. Okay, let's see what happened. Okay. Uh, so it is 5E minus 2 Z magnitude of Z. Okay. So it is asked what is the total amount of charge present? What is the total amount of charge present? Here, um, so actually, so this is very clear. Okay. So, total amount of charge present, what you need to do to find the total amount of charge? What you need to do? Here you no need to apply the Gaussian law. Okay. What is you need to do? This is a surface charge. This is a surface charge density. Okay, it is a surface charge. Now you are asked to find the surface charge. So what is you need to do? So that is the cylindrical surface. It is a surface in a cylinder, this surface. Okay. So you need to find the amount of charge present in this surface. Okay. So the surface density is given, charge density is given, surface charge density is given. So what you have to do? So the Gaussian law is not related with that. What you need to do to find the total Q? If the rho S is given, what you need to do? I think I explained it when I hear this. To find the total charge, what we need to do? This is Gaussian law. Now we are not going this one. Now we are not using this one. We have to use this. If it is volume charges, we have to do the volume integration. Line charges, line integration. Surface charges, what you have to do? You have to do the surface integration. Okay. So here, the surface charge is given. You have to do the surface integration. Okay. So what is the surface? What is the surface? Surface is from, okay, surface is this one, this surface, cylindrical surface. So you can consider the cylindrical coordinate here. Okay. So if you consider the cylindrical coordinate, if you consider cylindrical coordinate, uh, so what is, so here the surface integration you should do. Okay. So what is the variable? You should do the surface integration. Now you know it. Please tell me. If it is a cylinder, and if you need to do the surface integration, what are the variable you need to do? You have the function here. What are the variable? What are the variable? This surface is related with what? You need to do the integration with respect to d phi and dz. Okay, with respect to z and phi. Okay, so I think I have explained it here. Okay, so that is why I just give you a brief recap. Okay, so this is okay. So if you need to do the surface integral with respect to a cylinder, okay, so you need to do the integration with respect to 5 and z, sorry, 5 and z, okay, not rho, 5 and z, okay. So when you are getting 5, the 5 is coming with rho, okay. So you have to do integration with respect to this one, rho d5 dz, okay. Rho is a constant, okay, it is not a variable, okay. So you have to do the integration, okay. You have to do the integration with respect to 5 and z along with rho. Okay, so I think I have correctly write it. Okay, d5 and dz, but this 5 is coming with along with rho. Okay, so rho d5 dz. Okay, so what is the function? Function is 5e minus 20 z distance. 5e minus 20 magnitude distance. Magnitude distance. Okay, magnitude distance. So this is the function we need to evaluate. Okay, so this is the function we need to evaluate. Okay, so to find the total charge, we need to evaluate with respect to z and with respect to 5. Okay, our function is 5 e to the power minus 20 z magnitude. Okay, so you need to do the integration with respect to d5 and dz, but this d5 is coming along with rho. Okay, so this is what you need to understand. Okay, so I think now you should be able to get this one. Okay, get this integration. It is not much difficult actually. Only the basic theory we are using for that one. Okay, okay. Now after getting this one, what is another challenge? To find the limits of this z and of this phi. Okay, tell me what is the 5 uh, limits? What is 5 limits? What is 5 limit? What is phi limit? Tell me, you need to tell that is. That is very easy. What is phi limit? Just tell me your answer, what you think. What is the 5? 5 means this, no? 5 you know. 5 is the, so if you consider any point, if you consider any point, okay. So that 5 is the orientation or the angle with respect to this x-axis, okay? Okay. For to whole surface, what is the limit of this 5? 5 is starting from here. Yes, very good. Okay. That is from 0 to 2, 5. 0 to 2, 5. Here, Z axis uh, limit is not given. That means what? Z axis also limit should be given. No? Or we need to get it somehow. So, do you think what is the limit for Z axis? Okay. So maybe it is from minus infinity to plus infinity. Okay. Okay. So it may be a infinite length surface charge. Okay. So that is why there is no limit given for Z axis. Okay. No limit given for Z axis. Okay. But we can the phi axis or phi also not limits not given, but we can image it. Okay. There is a finite limits, okay? But for z-axis, z-coordinate, there is no finite limits, okay? So I hope we have to get it from minus infinity to plus infinity, okay? Okay. Now I think with respect to 5, it is not much difficult, okay? If you integrate it with respect to 5, what you have is there is no variable in 5. So you will have 5 here. So 2, 5 minus 0, you will have 5 here. Okay. So you will have minus infinity plus infinity. This is Z. Okay. 5e minus 20 into 2, 5. This is the result coming from this derivation. Okay. If you consider this derivation, the result is 2, 5, okay? Because there is no variable. This is a constant, okay? So constant I get out. So constant is there, okay? So this one is 2, 5, D is, okay? So you can get this 2, 5 and 5 out, 10, 5, okay? So you need to do the evaluation from minus infinity to pi plus infinity e to the power minus 20 Z, okay? D Z, okay? So if you evaluate, okay, now these are maths, okay, okay. So I will do this, okay. Anyway, I think it is better to check with the maths one whether my integration is correct or not, okay. So you know that, for example, if we do the integration, um, let's say that this is sine theta, this is sine theta, okay. So if I do the sine theta integration from 0 to 2, 5, from 0 to 2, 5. Okay. So what is the answer? Sine theta, sine theta uh, is minus cos theta. Okay. So minus cos theta is there. So 0 to 2, 5. Okay. So minus cos 2, 5. Cos 2, 5 is like this, no? This is 5. This is 2, 5. Cos 2, 5 is 1. Okay. Cos 2, 5 is 1. So minus is here. Cos 2 5 is 1 minus cos 0. Okay, cos 0. So it will be again 1. So 1 minus 1, you will have answer 0. Okay. So if I integrate sine theta from 0 to 2, 5, answer will be 0. Okay. So integration means I am finding the area of this cycle, the half cycle, and area of this half cycle. And I have to get the algebraic sum. Okay. So this area is equal to this area, and these are minus. So minus and plus cancel, and I will have 0. Okay. Can you remember that at A level? Okay, I'm not sure. If we do the integration from sine theta magnitude, what is the answer? The magnitude means, okay, sine theta magnitude means the plus value. Only we have to consider the plus value. Okay. So if you consider it 0 to 2, 5, okay, so it is like this. Okay. Actually, what is this magnitude sine 5 given? Magnitude sine theta given. This is the full wave rectified signal. Okay. This is the full wave rectified signal. Okay. So in signal and system. Okay. Okay. So that is magnitude. Okay. So you will get this one. Okay. So if you do this integration, okay. So you have to do this integration by two parts. Okay. So you have to do one from 0 to 5 here. 0 to 5 here. Sine theta. Okay. So you will have, and again you have to calculate, you have to add it from here to here, okay, here to here, okay. So that is equal to this one, okay. Then you can just remove this one and you can have 2 here, okay. So this in this area and this area is added, okay, like this, okay. So sine 0 to 5, that is minus cos theta 0 to 5, no? So cos 5 is minus 1. Cos 5 is minus 1. This area, this one. Cos 5 will be minus 1. And cos 0 is again minus, again 1. So it will be minus 1. Okay. Minus minus 1. Upper limit and lower limit. So it will be minus 2. It will be minus 2. Okay. It will be minus 2. Okay. So the answer is minus 2. Not minus 2. It will be minus 2 into 2. It will be 4. But answer should be plus 4. Okay. Okay. So anyway, it is like this, no? Okay. It is like this. If we have the magnitude, you have to do in this way. Okay. So maybe you can check this with your maths lecture. Okay. Maybe with Mr. Darshana. Okay. You can check. Uh, so I think same thing you have to apply here. It is from minus 20, the magnitude desert is there. Okay. So you know that if we consider normal function minus ex normal function, okay. So it is like this. It is like this. Okay. It is like this. Okay. So this is 0, infinity. Okay. So if you integrate this e to the power minus x from, actually you can't integrate this minus infinity to plus infinity because you will not get the finite value here. Okay. Because e to the power minus x, you will have e to the power minus x minus, and you have to apply the upper limit. If it is minus infinity plus infinity, okay. So at plus infinity, it will be e to the power minus infinity. So it will be e to the power minus infinity and it will be 0. the minus value is there. And if it is minus, okay, e to the power minus minus infinity, so it will be plus infinity. So e to the power infinity is infinite value. So you can't get the value here, okay? But we can evaluate the integration of e to the power e to the minus x from minus infinity to plus infinity. Sorry, from 0 to plus infinity. Okay, so you will have e to the power x minus the limit is 0 to plus infinity. Okay, so if you apply plus infinity, the minus is there. If you apply plus infinity, e to the power minus minus uh, sorry, plus infinity. Okay, if you apply plus infinity, it will be e to the power minus infinity. Okay, minus infinity, e to the power minus infinity. That means e to the power e, like this you can write now. Okay, so e to the power infinity means again you will have infinity. So infinity is divided by 1, you will have 0. And you can get it from this function also. If the theta is going to infinity, if the x is going to infinity, plus infinity, ex is reaching to e minus x is reaching to 0. Okay. So you can use this graph or you can use this logic. So e to the power minus infinity is nothing but e to the power minus infinity is nothing but 0. Okay. Minus e to the power 0, e to the power minus x 0. E to the power 0 is 1. E to the power 0 is 1. So you will have 1 here. So e to the power minus infinity, you will have 0. 0 into minus 1. And you have minus here. So the answer is 1. Okay. So if you evaluate this e to the power minus x with respect to dx, okay, this is with respect to dx, okay, always it is with respect to ds. From 0 to plus infinity, you will have one answer that is 1. Okay. So this answer is there. Okay. So I think, okay, I think when you are evaluating this integration, where is our integration? This one. Okay. So when you are evaluating this integration, okay, what is that? Evaluating this integration. Okay. Okay. So you have to do this integration. You have to basically do this integration. That is minus infinity to plus infinity, then 5 e to the power minus 20 is that e is that. Okay. So here minus infinity to plus infinity. No? Okay. From here to here, you have to do the integration. Okay. From minus infinity to plus infinity, you need to do the integration. Okay. Okay. So it is z, no? It is magnitude of z. Okay. So I think I'm not sure. Okay. I'm not sure this. Okay. I think if we do the integration, okay, if we do the integration from 0 to plus infinity, e to the power minus 2z dz, and if we get it, multiplied by 2. Okay. So this should be equal to this one. Okay. This is actually, I am not sure. Okay. This is actually, I am not sure. Okay. So maybe I will check with Dr. Udesh. Okay. I will check with Dr. Udesh because we don't have answers. No? If we have the answer, uh, we can compare. Okay. So maybe this way you can evaluate this integration. I think it will be okay. Right? Exam එකට ආවොත් මේ විදිහට කරලා දාන්න. හරි? මට මේක හරියටම logic එකකින් තේරුම් ගන්න අමාරුයි. So try to find a way to do the integration of this part. Okay. Actually, problem is this magnitude and this limits. It is from minus infinity to plus infinity. Anyway, this should be evaluated. This can be evaluated. Right? Some integrals we can't evaluate. සමහර integrals තියෙනවා අපිට evaluate කරන්න බෑ. උදාහරණයක් විදිහට e to the minus x minus infinity to plus infinity. මේක evaluate කරන්න බෑ. ඒ කියන්නේ මෙයාට එන්නේ infinite value එක. හැබැයි මෙතනදී අනිවාර්යයෙන්ම finite value එකක් එන්න ඕන ඇති. හරි? මම ඒකයි එහෙම හිතුවේ. එතන මේක තියෙනකොට මේ විදිහට ගන්න පුළුවන් කියලා අර sin එකත් එක්ක compare කරලා. Okay. I just compare it with the sine function and rectified full wave rectified function and think. Okay. But anyway, I'm not sure. Okay. If this is correct, I think you can do the integration easily. Okay. So it will be 25. Okay. 25 is 2 into 2, 5, 25. E to the power minus 20 is z. So it is divided by again minus 20. Okay. So you have to do the integration from 0 to infinity. Okay. So e to the power infinity. So minus is there. Okay. Minus is there. So minus 20 minus 5 is there. Okay. Minus 5 is there. Minus 5. 20, 20 cancel. Minus 5 is there. Then e to the power 20 infinity. That is e to the power minus infinity. So it will be 0. And e to the power 0, it will be 1. Okay, so you will have 5. Maybe this is the answer. I hope this is correct. Okay, but I am not sure actually. Okay, this is not sure. I think you better check with maths guy or I will ask Dr. Udesh. Okay, and maybe Dr. Udesh maybe not concerned this kind of question very much. Okay, he doesn't have time actually to concern. Okay. So sometimes if there are very hard integration is there, sometimes the maths lectures are also get the instruction from Dr. Udesh. He is the maths expert. But I don't think he will do the concern. Anyway, if I can contact him and get this verified, I will let you know. Okay. So meanwhile, maybe you can contact your maths lecturer, or maybe you can check how we can do this kind of integration. If we are given this kind of integration, how to do it, okay? So if you have a tool, so there are some maths tool to do the integration, no? If you are using a tool, so you can compare this result, okay? So try to do this integration. Our logic is our development is okay, okay? So basically we have to do this integration, okay? Basically we have to do this integration with this limit, okay? So you need to understand that, okay? Okay, so I think there is another part, how much electric flux leave the surface flow. Now there is a limit for Z axis, okay? So the same integration you can calculate with the limit from Z axis. That is the limit is given from 1 to 5. Okay. You need to do the conversion. Okay. Sorry, we drop this row. Okay. The row is also there. rho is equal to 8 centimeter. So you have to convert it to meter. Okay. So final value, final answer, the row is also should be there. Okay. We have dropped the row mistakenly, by mistake only. Okay. The row is there. Don't get confused. Okay. Row is there. මේ row තියෙනවා අන්තිම මේකේ අපි දැන් row එක හලලා ගියේ. මෙතෙන්ට එනකොට row එක හැලිලා. දැන් ඔකට්ටිය මේවට පොඩ්ඩක් අවධානයෙන් ඉන්නවා නම් මේ තේරෙනවා මේ මම row එක හලපුවම ඔකට්ටියට ලක් දාලා මතක් වෙනවා මේ. මෙතන row එක නෑනේ කියලා කියනවා. වැඩි තියෙන ඔකට්ටියත් වැඩි අවධානයෙන් ඉන්නේ නැති එක. හරි. So this row should be there. Okay. Uh, it is a constant, no? So all time row is there. Okay. So when we are doing this, row is there on this. Row is there. Okay. So for a final value also row is there. So row is 8 centimeter. Okay. Uh, and here the limit is given, the finite limit is given. Okay. So you can apply finite limits, that is from 1 to 5. Okay. That is from 1 to 5. Maybe you have to we will have to convert this to meter. Okay. Because this is given in meter, no? Okay. This is given in meter, square meter. So you have to convert all these length to meter. Okay. So you have to convert this to meter. So that will be your limit. Okay. That means 0.012, 0.05. Okay. So that is your limit. So again, we have the problem integrating with this one. Okay. So you need to have a proper way to integrate this. Okay. Okay. So I hope we have done 3 questions. Okay. 3 questions related with Gauss law. Okay. Actually, for the last question, we no need to use the Gauss law. No? There is what is the last question we found? So this one surface, what is the total amount of charge present? Here. Okay, this one you have to do the integration. Okay. Now here you are asked to find the electric flux. Okay. Electric flux leave the surface. Electric flux. Okay. For that one you have to apply the Gauss law. Okay. For that one you have to apply the Gauss law. Actually not the Gauss law. Okay. Again electric flux is equal to Q. No? Okay. So if you found the Q, okay. If you found the Q, you can find the electric flux. Okay. So for this question, actually, we no need to apply the Gauss law. Okay. Only we have to do the surface integration. Okay. So that is that. So shall we stop now? I think another one question maybe we can try to do. Okay. So can you try to do this question by yourself? Maybe next week I will discuss this one. Okay. So it is given in vector. Okay, it is given in vector form. That means you have to consider all the direction. Okay. For example, here for first example, we have to consider only the Z direction. No, only the Z direction. For this one, we have to consider only surface. Okay. So here actually no surface integration. So this is just the surface integration. Okay. අපරාධී ප්‍රශ්න කරේ. කමන්න මේකෙන් ඔකටට හොඳ මේකක් හම්බුණා අර වගේ එකක් කොහොමද ඉන්ටග්‍රේට් කරන්න කියලා. Ah, sorry. Sorry. I will do it. Okay. So actually, we have done this. So try to do this one by yourself. Okay. And this one we have done. We have applied the Gauss law here. Actually, for this one, we no need to apply the Gauss law. Okay. We have to do the surface integration. Okay. So when we are doing this one, you can see that here the only one direction is there, Z direction. Okay. But if you consider this one, okay, if you consider this one, there are two direction given. Okay. Uh, so maybe you have to apply the Gauss law for this direction. Okay. Again, you have to consider the direction also. Okay. Mm. So try to do this question by yourself, and the divergence also you need to find. Okay. I think you know what is divergence. Uh, mm, just explain it because there is a the divergence is related with the Gauss law. There is another Gauss law form that is called the vector form of the Gaussian law. Okay. So the vector form of the Gaussian law, we are using this gradient operator. Okay. So this is a vector operator, gradient. Okay. So if you consider the gradient operator, okay. So if we have given a x, y, z coordinate, okay. So we can find the gradient like this. Okay. We have to do the differentiation with respect to x, y, and z. And if we get the uh, addition, we can find the gradient. Okay. So if you have a scalar, if we find the gradient, so the first is that the scalar should be differentiate using x with respect to x, y, z. Then if we get the gradient of a scalar, we will have a vector. Okay. For this one, we will have a vector. Okay. So the gradient is actually the point in the direction it with phi is increasing most rapidly. Okay. This phi, it is a scalar that is, okay, wait, okay. I will explain. I will come back to your problem. Okay. Uh, uh, so that is the direction. The phi is increasing most rapidly. Okay. And uh, okay. So if we get the dot product of a gradient and a vector, this will be a vector. Okay. So you know that for a Gaussian vector form, the gradient operator is dot product with the E field. E field is a vector, and it is equal to the flux density divided by epsilon naught. Okay. So this is the vector form of the Gaussian law. So divergence is related with this. Okay. So we need to get the vector product with the divergence. Okay. Dot product. Okay. So this is the divergence, and we need to get the dot product with the vector. This is the vector. Okay. So you know that if this x hat is multiplied by x hat, it will be 1. Okay. So ax, so this is the vector in x direction. Okay. So ax into the differentiations by dx, you will have a value, and x naught, you will have 1 here. X naught into x naught, this is dot product, so you will have 1 here. The, 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 the dot product of these two vector, it will be 1. I explained it, okay, previously, okay. And if you get this one and this one dot product, what happened? If we get x hat, y hat dot product, what is the answer? you have to get x hat magnitude, y hat magnitude, cos, cos, bit, cos of the angle between these two vectors. What is the angle? It will be 90 because x and y are perpendicular. So cos 90 will be 0. So if you get x dot x direction vector with y with direction vector, unit vector, you will have the answer 0. Okay. So others are will be 0. Okay. So you will only have this one. If you consider this one, if you have the vector dot product, this y hat dot y hat, you will have 1. Okay. So ay into dy, you will have this term, but other terms, for example, y hat x hat, it will be 0. Y hat z hat, it will be 0. Same way, if you consider this one, z hat, you will have 1. So az, dz, you will have, the derivation is there. Okay. But others are 0. For example, x hat, z hat, it will be 0. Y hat dot z hat, it will be 0. So if you get a divergence of a vector, you will have this one. Okay. So here there is no direction. The vector part is cancelled. So this will be a scalar. This will be a scalar. Okay. Actually, this rho is a scalar. That is a density. The charge density. So it is a scalar. Okay. So that is the divergence. Okay. So maybe you can keep remember this one. Okay. This is a divergence. Okay. So when you are going to do this one, you have to find the divergence. Okay. So first you can find the D. So you can find the divergence, I think here. So what is how you can find the divergence? Delta hat dot D. What is the divergence of this D? Okay. So you have to get the dot product with this gradient operator. So you will have 2x square y with respect to da by x. Okay, with respect to da by x. This is d, okay, d2xy with respect to da by x plus 3xy square. This is d with respect to da by. So this is the answer. This is the answer, very easy. Okay, so note this one, note this one. Okay, so ax and ay only there. So z is 0 here. So no z. Okay, so you will have only ax and ay. Da by ax, da by x, da by ay, da by y. Okay, so this one. Okay, so you can calculate this divergence. So, okay, so then you have to estimate the total charge enclosed within the cube using equation 8. Okay, so try to do this one also. Okay, and if you need, please write this one. This is the divergence. Okay, this is a divergence. Maybe for the exam you will have to use this form. Okay, divergent form to find the things. Okay, then you can use this one. Okay, so maybe you can note this one. Okay, so we will stop. Try to do that 3.17 example in your reference book. Okay, so next week we will discuss, or maybe I will try to record it and upload. Okay, then we can finish that Gaussian also. Okay, so wait a minute. You need to mark the attendance also. Okay, so I will stop the recording.